welcome to another Stata video. My name is Stefan Eriksson, and in today's video we're going to be taking a look at one-way ANOVA. So let's start with what is it and what is it useful for? Well, if you want to test if the means among 3 or more groups are statistically different from one another, then ANOVA is for you. Why is it a one-way? Well, we're testing the impact of one predictor on the response variable. Had it been 2 predictors, it would have been a two-way ANOVA, and you can pretty much see where it's going from there. You could also think, hey, couldn't I have done it for just 2 groups? Do it needs to be 3 or more? Well, the answer is yes, you could. But then it would just be the same as a difference in mean test, so a simple t-test would do. You could simply also just go and check my video for balancing test if you're interested in just that or for other applications. So let's get on with today's example. We're going to be looking at this nice little data set that Stata has, so you can also replicate it at home. Let's take a look at what we actually have. We have the data set on 58 patients for a given drug, for a given disease, and this systolic. We want to test whether this systolic, say, it even says here what it actually is if you're a little unsure. Then you can see whether that is statistically different among these 3 or 4 different types of drug use here in this particular data set. So that's what we can do with an ANOVA. So what we can do first to get a good idea of the data, because you should always do so, is to just, I would say, graph it. We can do that by a box plot, or in this case, we can just tabstat it to get some statistics out for each of these different groups. So for instance, I have my variable here. I'm using tabstat in this case. I'm going to sort it over the drug, so we're going to get for 4 different groups. And what is so nice about this little command is you can simply customize it in the sense that what statistics do you want? We want mean. We want the standard deviation, I want the number, I want, say, minimum and maximum. That should be all you ever want, to be honest. I put it up here, and we quickly get a nice little overview here. What do we have? The mean, standard deviation, n, and these kind of things. Please pay attention to this table, because it may come in and be, familiar in a little moment, right? So what can we do now? Well, ANOVA will see if these means are statistically different from one another. So we're going to use the one-way command, and for more advanced ANOVA topics, you can use the ANOVA command. But for this here, the one-way command is more than enough. So it's very simple. It's simply just one-way systolic, very simple build-up. And then you can think about, probably the next thing is what kind of drug we're doing it or what kind of grouping variable we're using. So that's okay. And we can also add tabulate here. And what you see with the addition of tabulate here, so let's just run it and see what we actually get. This first part here, if I scroll up again, scroll down again, looks pretty much the same, because it is pretty much the same. And it is the same in the sense that we just don't have min and max. But what is interesting here, we can see the F statistic here, we get an associated p-value, and we now see that there's a significant difference between the groups. But, that's nice and all, but now we know that they're statistically different from one another, but we don't know which groups are statistically different from one another, and that we need to go one step further for a multiple comparison test, they call it. So we can see if it's group 1 versus 2, 2 versus 3, and whatnot. And you would think about, wait, I got 4 groups, so how many combinations do I have? It's basically, well, 3 factorial, right? So here we have 3 times 2 times 1, because we've got 4 different groups. It's kind of like a round robin in football. So what do we do here? We use the PV means command. So it even comes here, very simple. Then we do it for systolic again, because that's the one we want to test between. We want to do it in this case over various drugs. I could get the confusion between when to use by and over, but that is on the command. So as long as you know it's the command, you can always check the file to see how it should be written for this particular one. Then if I don't write anything more, the standard is it doesn't make any corrections for multiple groups, but in fact there exist many different corrections, and I'll invite you to go for the help file for PW mean. We're just going to use, say, the Bonferroni here. That's one you can use. You can also use the Turkey method. There's many different ways. So we can use the M compare and then add in which one. So barring my spelling, let me see if I can spell it correctly, Bonferroni. And then of course we want the effects to be shown here as well. You can always check what these kind of things do. So we go in here, we check it, we run it, and I hope I typed it correctly. We get all these different things here. You see, number of comparisons is 6, but our basic combinatorics total is the same. Then we can see all the different groups compared here. We see what the contrast is, we get the standard error here, and more importantly, we get the p-values here in this column here. And what you see is 1 and 2 are not statistically different from each other, but quick view says at the 1% level, 3 versus 1 is 3 versus 2, and on the 5% level, 4 versus 1 and 4 versus 2. But 2 versus 1 and 4 versus 3 are not statistically different from one another. But that's all there's to it. So if you want to do a one-way ANOVA in Stata, it's easy peasy, at least for the one-way part. We will continue another video with the more advanced ones. But for now, that is all what I have here. So I hope you enjoyed this class in Stefan's Classroom, and I hope to see you back for another class in Stefan's Classroom. Bye-bye.